Okay, so this one here, your main strategy, if you see a root in an equation, you want to get the root by itself on one side and then square both sides to get rid of it. You're not going to face it today, but if there were two roots in a problem, you would get one root on one side by itself, square both sides. You would still, when you're done, have another root left over. And so you get that root by itself and then square both sides. But here we've got the root by itself. So the next thing I'm going to do is square both sides. That means on the left-hand side, I'm going to have to FOIL x minus 4 times x minus 4. And on the right side, the square gets rid of the square root. Now I'm going to FOIL that. So x times x is x squared, x times negative 4, negative 4x. Inside another negative 4x, and negative 4 times negative 4 is 16. Okay, now I have quite a few terms. I want to maybe simplify and then move everything to the same side. So I have negative 4x and negative 4x. That's going to give me negative 8x. I want to move everything to the same side. If I'm going to use the quadratic formula, it doesn't matter if my leading coefficient is positive or negative, but I'm hoping I can factor. So since this is a positive 1x squared, I'm going to move all the terms to the left to keep that leading coefficient positive. So let's add 5x and subtract 44. That's going to leave us with x squared minus 3x minus 28. Thinking of two numbers that multiply together to get negative 28 and add up to negative 3. And that's going to be negative 7 and positive 4. Then set each piece equal to 0, because when two things multiply together to get 0, one of them is going to be 0. And when I solve x minus 7 equals 0, I'm going to get 7. And when I solve x plus 4 equals 0, I'm going to get negative 4. Okay, but danger, danger. Anytime your original equation has a variable in the denominator of a fraction, we have to check it because we're worried about dividing by 0. Also, if the original equation has a variable underneath an even root. So if it was a cube root, I would not have to worry about it. But since this is an even root in the original problem, I must verify. So if I go ahead and substitute in 7 into the original, I'm going to end up here with 3 is equal to, and then I have the square root of 9 there, and I'm going to get 3. So this one's true. But if I plug negative 4 back into the original here, negative 4 minus 4 is negative 8. Without even doing any more simplifying, the square root of something is not going to give me negative 8. If I go ahead and finish simplifying there, I'm going to end up with positive 8, but we've got negative 8 equals 8, not true. So that means that we want to throw out this one, and our only answer is going to be 7. So guys, one more time, please make sure you remember, if your original equation, if there's a variable in the denominator of a fraction, or there's a variable underneath an even root, then checking your final answers, yeah, it's not optional, you've got to do it, because they're called, fancy word is extraneous solutions. And your extra solutions, you throw them out, and that's what's left.